Hi friends, my name is Benedict George. This is video number 5. In this video, I'll be showing you that length contraction is a ill-conceived concept. It is wrong to say that some object in moving frame of reference will become smaller in length as compared to the stationary frame of reference. So let us move. So these are two frame of reference S and S prime. There are 2 points. Let us say there are 2 points, point A and point B in the S prime frame of reference. So then S prime frame of reference moves with velocity v. So what will happen to point A and B in moving frame of reference? So we will use the formula x prime is equal to gamma x minus vt. Though this equation is not altogether right, but we will consider it to be right at this moment. Now, using this equation, point B, first we'll speak about point B, will move by some transformation towards right. So point B will move here. Say, there is some transformation. But what about point A? There will also be a transformation for point A that is equal to the transformation in point B, because transformation factor is same for both, right? So for point A also there will be transformation. When there is equal transformation, what will be the distance? This and this, there is no change in distance. They will shift towards right, but there will be no change in distance between point A and B. So in length contraction, these scientists are trying to prove that there is length contraction in moving frame of reference, which I have proved that this is wrong concept. There will be no length contraction. What they are doing is they are making this frame of reference, one frame of reference as fixed at one point, and because of that they are showing that there is length contraction, but there will be no length contraction, right? So if you have once there are these 2 points, then if you have one piece of wood or steel with 2 point XA and XB similar to point A and B, they will also transform similar to A and B, and they will shift towards right, but there will be no change in length, right? Next, now in this is a derivation of Lorentz transformation for position. This one you can see here, there is a shifting of point P to P prime. It shifts from P to P prime, right? So then the origin O prime also shift to O1 prime. What they don't consider in this, that is because of this all these problems are happening and we are not getting the proper results, right? Next, so this is a derivation they use for length contraction. So how they are doing, actually this x prime b, this point x prime b is for the moving frame of reference. See, this is moving with velocity v. But what they are showing in this, see, proper length of or rest length. So this x prime b minus x prime a, they are showing as the rest length, which is wrong. It is actually relative length, right? Next, xb minus xa, they are showing as relativistic length. This one. That is actually the proper length or rest length. So they have shifted this and this. Because of this, they are getting a wrong equation here, where the relativistic length is decreasing because of this equation. The relativistic length is lesser than the rest length, right? So how they have derived it, I'll derive it for you. The x prime b, first we consider. So we will take the equation x prime is equal to gamma x minus bt. So this x prime will be x prime a, this x will be x b, sorry, x prime b. First we will take this one, x prime b, and x will be xb. We'll substitute these values. So x prime b is equal to gamma xb minus bt. So here we are taking as tb, time of d, right? Then x prime a is equal to gamma xa minus vta, right? We subtract this to find the length. This is the distance from O prime, this one, both x prime b and x prime a. So we subtract, we get the length. We subtract it. So x prime b minus x prime a is equal to gamma. I'll take common outside. So x b minus vtb minus xa minus vta. ठीक है, we'll shift. So x b minus xa, we shift the position, and minus vt minus vta. Right? ठीक है, minus, right. Okay, now x, this tb is equal to ta. The reason being, when you find the length from this frame of reference, we have to find the length of this and this at the same moment. So when the time taken by this are equal, so TB is equal to TA. That means this is cancelled out. So what is left is x prime b minus x prime a is equal to gamma x b minus xa. So what is xb minus xa? This is your here. What they have shown is wrong, but delta L. So relativistic length they have shown, and this x prime b minus x prime a they have shown as proper length, that is delta L0, and they have come out with the wrong equation, which is relativistic length is equal to rest length divided by gamma. Gamma is less than 1 when it is, gamma is always more than 1. So when you divide by any value or rest length with this, you will get a relativistic length which is less than the rest length. Because of that, they are showing that it is a length contraction. But I have already proved it is not the case of length contraction in this case. Now but still there is a length contraction. I'll show you. I'll show you later on. Let us see here. So in this moving frame of reference, if there is some object is kept, there is no length contraction, right? So I have derived my formula. I have given you this formula in video 1 and video 2. So the formula of Lorentz transformation position is x prime is equal to, I have given transformation factor as beta, and this is x rest. So x prime will take it this one, x rest will take it this one, right? So x prime b is equal to beta x b at rest, x b at rest. So for a, x prime a is equal to beta x a at rest. We subtract it. So x prime beta minus x prime a is equal to beta. I'll multiply this. X b at rest minus beta x a at rest. Right? Now what is beta x b at rest? When the value of xb, when you multiply with a transformation factor, you get what? X prime b. So this is nothing but x prime b, and this is nothing but x prime a. So x prime b minus x prime a is equal to x prime b minus x prime a. That means there is no length contraction. Right? Next. Now, what I want to convey is that there is a length contraction, but how that length contraction can be conceived? Let's take an example of muon. So there is earth and muon is coming from here. Muon has a velocity of 0.995 meters c. It is almost close to the velocity of light, right? The muon is here, and its half-life is 2.2 into 10 to the power minus 6 seconds. So the muon, when it comes from the outer atmosphere to the earth, okay, once it is formed here, its half-life is here. From here to here, it should die, because its half-life is 2. So when you calculate with the speed of light, it only go up to here. This is the distance it can travel, that is 660 meters. 660 meters, sorry. 660 meters it should travel, and it gets destroyed. But it travels to the surface of the earth. We have experimentally found that muon travels to the surface of the earth. So how it is possible that muon can travel from here to here? Because it should get destroyed here at this point, 660 meters. So the reason is very simple. The muon is transformed because it is going with the speed of light. It's just transformed by using formula x prime is equal to gamma x minus bt. Once this is transformed, so the distance will not be here, it will be somewhere more beyond that. It will go beyond that. Because what we are thinking it is at 660 meter this time, no, at this time it is beyond this here. So when it goes beyond it, because this position has changed, the position we thought theoretically was here, this position it should be, but because of this transformation, when you apply this formula, this will come here, right? So at 2.2 into 10 to the power minus 6 second, actually this position was here. It has transformed. So if you see from the other side, from the muon side, what is happening is the muon is seeing that this distance has actually, the whole distance has contracted. That's why in 2.2 seconds it is destroying, but this distance has contracted because this position, the theoretical position is this, because of the transformation it has come here. So this is the length contraction for muon. That doesn't mean that there's something is kept in moving frame of reference, the length will be contracted. No, that is wrong. Length contraction, there is a fixed point. The frame, the reference frame is here. This is his fixed point it should reach. Earth is not a frame of reference for this muon. This is only a point P. It has to reach here from this frame of reference, somewhere 5,000 meters, say. Here to here 5,000 meters is there. Right? So from here to here, this is a point P which it has to achieve, point P to Earth. And this is the frame of reference from where it will move here with the velocity 995.995 c. So it will transform in this toward this side, move faster, the position will shift more faster, and because of that transformation, the length which is actually 660 meter will increase to 5,000 meter because of this transformation. Actually it goes beyond that, so you are able to detect muons here on the surface of the earth, right? So this is the length contraction for the muon, not for the objects moving in the frame of references. Now if you see the example of muon, right, let us see here only. If you see the example of muon, how can you explain this movement, this transformation of the position from here to here with the help of this? One way is showing with the help of relativity, but if you don't have these formulas, then how can you explain? You can only explain through the acceleration. It is only you can explain through acceleration. You cannot explain in any other way. So you have to consider acceleration. Now let us see here. This was the position of P in stationary frame of reference, S and S prime, and then the point P shifts to P prime. If you see in some different way, that means point P has shifted here. Once point P shifts here, and V is the uniform velocity. V is the uniform velocity. It is going with a uniform velocity. Whole frame of reference. Still point P shifts here to P prime. Though this frame of reference also shifts actually. but they are not showing it. So this point P shifts from P to P prime. So this is going with velocity V. P should also move with velocity V actually, but is shifting to point P to P prime. Once this shift is there, you can't have any other theory beyond acceleration, because it has accelerated. That's why it has moved from P to P prime in the same time. So we have to consider acceleration. We have to consider acceleration without force. It is acceleration without force. Now I'll give an example of acceleration without force. This is universe. It is expanding. And they say without any force. See? Acceleration without force. See? Acceleration without force. In next videos, I'll explain you that this frame of reference, the moving frame of reference, is actually an accelerated frame of reference. Okay, that I'll let you know in the next videos. But see our universe, it is expanding without any force, acceleration without any force. Now, give one example to me of any particle, any object which is at rest without any force. There is no particle, no object which can be at rest without any force. You know why? The reason is very simple. Every particle, every object is made of energy, and energy always vibrates or moves. And any particle which will vibrate will always move. Therefore, there is no particle which can be at rest. Theoretically, no particle. And when it moves, say if we apply some force on the particle and we keep it on rest, right, and we remove all the forces around it, it will vibrate. All every particle, let it be very small, it will still vibrate. When it vibrates, there is, or in the atom, there is motion in the electrons. Motion. This motion will be uneven motion, and when it will be uneven, it start vibrating, and when it start vibrating, it start moving, and when it start moving, it is started from 0 to some velocity. That means there is acceleration. Acceleration without force. There is no force applied. This is what I propose. Secondly, I also propose that we can go beyond the speed of light. We are not trying to go. That is a reason we have put constraint on us. I'll tell you how they have put constraint. Here they have put a constraint on us. This too. In the equation or derivation of position, Lorentz transformation, this is a constraint they have put on us with the help of C. You are not supposed to go beyond the speed of light. You can go. I'll explain it to you in the next videos. So we should consider acceleration without force. I will explain that every frame of reference which is moving with uniform velocity is actually accelerated frame of reference. Right? So this is my email ID. You can send your suggestions, your criticism to this email address. Let us discuss on whatever I am proposing and develop a new theory of special relativity. Kindly share with people who know relativity well, who can understand and who are learning, and the professors who are teaching. This is, I have taken references. There are a lot of references available on the net. Thank you so much. We will be meeting in the next videos.